In this video, we're going to go over the one question that we skipped in the last video, so question 7, and then we're going to the next section, which is solving exponential inequalities. I'm so sorry, the stylus is not working, so let me just fix it. All right. So now we are going to solve question 7. And basically, from this part, we know that x has to be greater than 0, and this tells us that y has to be greater than 0. So now, keeping this in mind, we can solve 10 to the power 4, right, is x squared y. And 10 to the power 18 is x to the power 4 over y cubed. And from this, I know that y is equal to 10 to the power 4 over x squared. So that is the value of y. And I can substitute that y here. I can say that 10 to the power 4 over x squared cubed, right? And that gives me x4 times, and I'll leave the simplification to you because I think it's good practice, x to the power 4, which is in my numerator, times x to the power, this thing is going to pop up to the numerator. So x to the power 2 times 3 is 6. Divided by 10 to the power 4 times 3 is 12. And when I multiply by x to the power 12 on both sides, I get x to the power 12 plus 18 is equal to x to the power 4 plus 6 is 10. So x to the power 10 is equal to 10 to the power 30. And therefore, to get x, I need to raise both sides to 1 over 10, right? 30, 1 over 10. And therefore, I get x is equal to plus or minus, because this is an even power. So the roots, when we look at the roots, we're going to get both the positive and the negative value is going to satisfy it. So we get 10 to the power 3. 30 divided by 10 is 3. But because x is greater than 0, we're just going to get x is 10 to the power 3. And we can calculate log base 10 of x. That is just going to be 3, right? That is, I think, what the question asks you to find. Log base 10 of x is just going to be 3. And now we can substitute this value. Y is 10 to the power 4 over 10 to the power 3 squared. So y is 10 to the power 4 over 10 to the power 6. Y is 10 to the power negative 2. And therefore, log base 10 of y is log base 10 of 10 to the power negative 2 is just negative 2. So log base x, this comes from the fact that x is 10 to the power 3. And this is 3 times log base 10 of 10 is just 3. So there you have it. Your answers are negative 2 and 3. And let me just quickly check it for you. It should be, yeah, negative 2, y is negative 2, and x is 3. All right, so moving on to exponential inequalities. Exponential inequalities. So basically, if you have, say, a less than b, or a greater than b, or a less than or equal to greater than or equal to, it does not really matter. But if you have this, we can easily add any number on both sides without affecting the inequality. We can say x, or we can subtract the same number on both sides without affecting the inequality. So this is something that we are allowed to do. We are also allowed, if c is a positive number, then we are also allowed to multiply on both sides without affecting the inequality. That is something to keep in mind. And this still works if it's less than or equal to. The only thing that we have to be careful about is multiplying, and even if you divide, if you're dividing by a positive number, that does not affect the inequality. The only thing that does matter is if you're multiplying or dividing by a negative number. So if a is less than b, or less than or equal to b, or a is greater than or equal to b, if you're multiplying by c, and c is less than 0, then you have to flip this inequality. So you're going to have to flip the inequality if you're multiplying or dividing by something that is less than 0. So that is something to keep in mind. And now we are ready to start our questions. But let me also show you something else. A to the power x is always going to be greater than 0. So this is what the graph looks like. This is for a greater than 1. This is 0, comma 1. And this is if, and I know it's a very poor graph, but the a is less than 1, greater than 0. I can just import actually the curve that we have been talking about. So here, if you can see that this is always bigger, it's always bigger than 0. It's always going to be above the x-axis, right? It's always positive, my output. And if you look at log base a of x, and usually we deal with positive bases, right? We only will have a greater than 0. But if you look at this, if your x is equal to 1, then your log base a of x is equal to 0. If x is bigger than 1, log base a of x is less than 0. And this is for a greater than, log base a of x is bigger than 0, right? If your x is bigger than 1, then your output is positive. If your x is less than 1, log base a of x is less than 0. So this is something you want to remember. So if your x is less than 1, it's less than 1, then your output is also negative. So that is something you want to remember. Why? Because when you multiply or divide by some log terms, then you want to make sure your inequalities are in the correct direction. And that is the same case if a, so this was the case for if a is greater than 1. What if your base is greater than 0, but it's less than 1? Then it's the opposite. If x is bigger than 1, then your log base a of x is less than 0 because it goes to the negative direction, right? And if it's equal to 1, log base a of x is still 0. And if x is less than 1, then log base a of x is positive. It's greater than 0, as you can see. So this is something to keep in mind. And now that we have that down, we can start. So I'll be doing A and B, or maybe A and C for every question. Or maybe we can try to do all of them. We'll see. But let's start with A. So I have 2 to the power x is less than 5. And my base is 2. So we look at this graph. Log A of x. My base is greater than 1, right? So my A is greater than 1 because A is my base. If my base is greater than 1, then I'll look at this part, this graph. These graphs. Anyways. Now, because if you look at the log function for a greater than 1, then you see that as x increases, the output increases. So the log function is an increasing function. If you put bigger values of x, if x2 is bigger than x1, then that means f of x2 is bigger than f of x1. That is what it means to have an increasing function. So because we have an increasing function, if 5 is bigger than 2 to the power x, then log base 2 of 5 must be bigger than log base 2 of 2 to the power x. And now we can simplify this. We know that this is 2 times x times log base 2 of 2 less than log base 2 of 5. And we haven't done anything that is, let's say, illegal in math. We're using the rule. We haven't divided by any negative numbers. We haven't multiplied by any negative numbers. So we don't really have to worry about the direction of our inequalities. Now, log base 2 of 2 is just 1. So when we just put 1 times x, then we get x is less than log base 2 of 5. And log base 2 of 5, you can actually put it in your, I don't think you can put it in your calculator. I'm not sure if your calculator is programmed to calculate the base, right? The other bases, but you can actually use a change of base because your calculator is not allowed to take in base 2, but it can take in base 10. And now using the change of base. So the change of base tells us that log, and again, I'll keep on, I know I've been saying this for a long time, but once we have covered almost everything by the textbook, then we'll discuss these extra formulas and extra things that are useful to know when dealing with logarithms. But if you have log base a of b, you can write it as a fraction with a common base. So this will go here, this will go here, and then you can write it as log base c of b divided by log base c of a. So log base 2 of 5, we can write it as log base 5 base 10 divided by log base 10 of 2. So x is less than, and this is your answer. Log 5 by log 2. And you can actually put it in your calculator. So log 5 by log 2. So that gives you x is less than 2.32 in 3 significant figures. And now you can solve b in the same way. So let's go C. If you have 2 over 3 to the power x, now your base here, your base is less than 1 because 2 over 3 is less than 1. So we're going to look at these graphs. 2 over 3x is greater than 0. So it's helpful to remember these graphs of how your exponential function and logarithm functions look like when you have a less than 1 and greater than 0, or when you have a greater than 1. So we have this. Now we can take the logarithm on both sides. We can take log base 10. So we can say log base 10 of 2 over 3 to the power x is greater than log base 10 of 3. And this gives us x log base 10 2 over 3 bigger than log base 10 3. Right? And now we have changed it to a base that is greater than 1. So actually we can look at now these graphs as well, because 2 over 3 is less than 1. Is less than 1. So because our base 10 is bigger than 1, 2 over 3 is less than 1, then that means that this value, this logarithm, is actually negative. So x, when you divide on the other side, you have to switch the direction of your inequality. So you have log base 10 3 divided by log base 10 2 over 3. And that should be your final answer for C. So log 3 divided by log 2 over 3, and the direction of the inequality has changed. So this is your answer, and you can put it in your calculator. So it says give your answer in terms of base 10 logarithm. So basically, yeah, that is how you approach these. So you can actually directly take log base 10. You don't really have to worry about taking log base 2 of something. So yeah, in A, my method was a bit inefficient, but just take log with base 10 on both sides. And remember, if it's positive, it doesn't matter when you divide, but if it's negative, the direction of your inequality will flip when you divide. So solve the inequalities, giving your answer in terms of base 10 logarithm. So let's do B and D. So it says 3 to the power 2x plus 5 bigger than 20. So because we want to write it in terms of base 10 logarithms, let's just take log base 10 on both sides. And because it's an increasing function, you don't really have to worry about the direction of your inequality. You are allowed to take log both sides. So when you take log both sides and you simplify, if this is bigger, then the log of this thing is going to be bigger. Log 3. Log 3 just means I have a base 10. So that is now, from this point onwards, implied. So I know that, hey, 2x plus 5, this, because 3 is bigger than 1, is going to be positive. So I can do log 20 divided by log 3. And the direction, I don't have to change my inequality. So 2x is bigger than, I can subtract by 5 on both sides. Minus 5. And now I can divide by positive 2 without worrying about the direction of my inequality. So I get log base 20 over 2 log 3 minus 5 by 2. If I divide by 2 on both sides. So yeah, x is bigger than, the textbook just gives the answer as half minus 5. But it's essentially the same thing. Minus 5, yes. And let's do D. D just tells me that I have 7 times 5 over 6 to the power 3 minus x bigger than 4. So now I can again take log of both sides. And because I'm taking log base 10, then I don't have to worry. If this is bigger, log base 10 of this thing is going to be bigger. So log 7 times 5 over 6 to the power 3 minus x is bigger than log 4. And the base is 10, it's implied. I can use the rules of logarithms to split this. Log 7 plus log, well, the 3 minus x is going to plop in front. Log 5 over 6 is bigger than log 4. Now log 7, I can subtract log 7 on both sides. 3 minus x. Log 5 over 6 is bigger than log 4 minus log 7. And now log 5 over 6. 5 over 6 is less than 1. My base is 10, is bigger than 1. So I just look at this graph for base bigger than 1. And 5 over 6 is less than 1. So it's going to be negative. So when I divide by log 5 by 6 on both sides, the sign of the inequality, the direction of the inequality has to flip. So now it's going to be less than log 4 minus log 7 divided by log 5 by 6. And this is because we were dividing by a negative number on both sides. Now I can add x on both sides. I can actually subtract. I can add. It's okay to add x on both sides. So if I add x on both sides, where would be a right place? Let me do it at the top. Oops. Okay, I think this works. Oof. Anyways, let me just solve it here. If I add x on both sides, I get 3 less than log 4 minus log 7 divided by log 5 over 6. And then if I add x on both sides, I get plus x. And now I can subtract this whole thing to solve for x. So I know that 3 minus log 4 minus log 7 log 5 over 6 going to be less than x. So this is my solution. So the textbook presents it as x bigger. So x is bigger. We have the correct thing. 3 minus, and log 4 minus log 7 is just log 4 over 7 over log 5 over 6. So it's the same answer. So it's the same thing. All right. So we have done 1 and 2. So I did 1b.